This is graphing standard form of a quadratic. So here's the standard form. You can see it here at the top. This is the standard form. F of x equals ax squared plus bx plus c. So each of these terms here, 4 and -8 and 1, those are a, b, and c respectively. So let's fill those in here in our table. So a is 4, and b is -8, and c is 1. This will become pretty important when we do the quadratic equation, which we're about to use to find the roots of this quadratic. So the first thing we're going to try to do is actually find the axis of symmetry. The axis of symmetry is given by this little equation. X equals -b over 2a. So let's fill that in. -b over 2a would be negative times a -8. That's -b over 2a. That would be 2 times 4. All right? So what we get is a positive 8 on top and an 8 on the bottom. That comes out, 8 over 8 is 1. So the axis of symmetry is at 1. What does that mean? Well, this is going to have a line that divides it right down the middle, and it's going to go right through. Here, let me change colors quickly to red. It's going to go right through 1. So here's 1 right there. And so we have, that is our axis of symmetry. This right here splits the parabola into pieces, 2 equal pieces. And so now that we know the axis of symmetry, that's 1. Let's record that here. So the axis of symmetry is 1. What we're going to do to find out what the vertex is, the vertex is the turning point. The vertex is the maximum or the minimum, whichever direction this parabola is pointing in. It's the maximum or minimum, and I can find that out just by the value of a. If a is positive, which it is here, right? A is positive, then the parabola is going to have a minimum because it's going to be facing upward. If it has a negative a value, it's going to be facing downward, right? The vertex is, the best way to remember it, I think, is to call it the turning point. It's where the graph turns, and there's only one of them in a quadratic. So let's find out what that turning point is. We plug in that 1 that we just found. We plug 1 back into the equation. So f of 1, what is that? It's 4 times 1 squared minus 8 times 1 plus 1. So 1 squared is 1 times 4 is 4. So we have 4 minus 8 plus 1. So that comes out to -3. This comes out to -3. So our vertex now is 1 and -3. So come down here, let's plot that. So -3 and 1 is right here, or 1 and -3 is right here. All right, there's our vertex. So you can see our quadratic starting to take shape. First thing we did was found the axis of symmetry. Then we plugged the axis of symmetry in to find out what the vertex is. All right. Second step, let's plot the y-intercept. This is much simpler. The y-intercept is simply this number right here. It's c. All right. So whatever c is, that is the y-intercept. How do we record the coordinates of the y-intercept? Well, the y-intercept is where x is 0. So this is 1 and this is 0. So let's plot that. 0, 1 is right here. Okay, that's our y-intercept. All right. Finally, we're looking for the roots, if there are any. Sometimes there are no roots. For example, when I say roots, what I mean is the x-intercepts. So we're looking now for the x-intercepts. There may be 1, there may be 2, and there may be none. If there are none, it would look like this. It would be a parabola that's over here. That never crosses the x-axis, and so it has no roots. But this parabola, you can already tell, like, let me run a rough graph through it. You can already tell that's going to cross the x-axis twice. So let's figure out exactly where those points are. This is going to be difficult because we're going to use the quadratic equation, because you can see this quadratic is not factorable. And let me explain a little bit more. So if I were going to factor it, I'm going to use my x method, and I'm going to use the first term, a, times the last term, right, the last term is 1, so 1 times 4 is 4. And the middle term, negative 8, goes on the bottom. And I'm thinking about what are the factors of 4? They're like 2 and 2 and 4 and 1. The problem is I can't get to negative 8 from there. It's just not going to happen. I'm not going to have a whole number solution for the roots here. And so what I have to do is I'm forced to use the quadratic equation. So let me show you what that looks like. So the quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now, if you have the quadratic in front of you, right, it's f of x equals, this one is 4x squared minus 8x plus 1. What we're going to do is we're going to put each of these terms in here very carefully, right? So 4, that's a, all right? And 8 is b, negative 8 is b, and 1 is c. So let's plug those in and see what we come up with. So we'll have negative times a negative 8 plus or minus the square root, do that again, the square root of negative 8 squared, right, that's b squared, minus 4 times 4, a is 4, times 1, which is c. And that's going to be all over 2 times a. A was 4, remember? Okay. So now we're going to have two answers. All of this is 64, or negative 8 squared is 64, minus 4 times 4, that's 16. So this is the square root of 48. So we're going to have 8, positive 8, plus or minus the square root of 48 over 8. All right, so this is really two answers. And that means it has two roots. So this is 8 plus the square root of 48 over 8. Okay, so x equals that. And x would also equal x minus the square root of 48 over 8. Okay, so let's compute both of those. This one, the square root of 48 is like 6 point something. Plus 8 divided by 2. It comes out to about, if you do this in your calculator, and let me just show you on my calculator here. So the square root of 48, let's see, second, here, I already got it up there. Second, square root, 48. All right, let's put that in. So I get 6.9, and then we do 8 plus second answer. That's about 14, and then we're going to divide that by 8, which is 1.86. Let's call it 1.87. Okay, so this is 1.87. That's our first root. Let's get the other one. So we're just going to change the sign here. It's going to be 8 minus square root of 48 over 8. So let's do that out. So square root of 48, like we said, was about 6.9. We're going to do 8 minus that answer. And then we're going to divide that by 8. And we get 0.133. Let's call it 0.134. Let's just call it 0.13. Okay. So let's call it 0.13. Okay. So those are our two x's. Let's plot them. All right. And you're like, how? How do you plot something like that? Well, this is where they cross the x-axis. So it's where y is 0. All right. And the first one, 1.87, let's just call it close to 2. So it's like right here. It's almost 2, but not quite. Okay, that's where it crosses the x-axis there. And then the other one is 0.13. Let's call it pretty much just about started off here. Not gone too far along this axis yet. I'm breaking this into like tenths, thereabouts. Okay, it's an approximation. Right, this is a sketch, but this is the best we can do without a computer, okay? So here's what we're going to do. Now that we have these points all plotted, so I've got my two roots. These are my two roots in blue. I've got my y-intercept here, all right? This is my y-intercept, and I've got my vertex here. I'm just going to connect them all with a line, and we'll call that good, all right? So I'm going to connect all of this with a line, but you actually have to touch the points, okay? Do better than me. Be better than Mr. Saroy. Okay, so we're going to call that graphed, all right? That's how you graph from the standard form of a quadratic.